Hi, I'm Joel Solon. I'm a technical trainer here at InterSystems, and I'm here today to talk to you about one of the storage models provided by InterSystems Iris data platform, the model we call globals. We love globals here at InterSystems, and hopefully by the end of this presentation, you'll start to understand why. So what is a global? A global is a persistent multidimensional array. It's a subscripted variable that stores data. So let's look at an example. A global can store any kind of data, whether just this simple value 4, or structured data based on some schema, or unstructured schemaless data, or a combination. There's no declaration of size or structure for globals. Processes can just add to globals, and the global grows accordingly. And when one process stores some data in a global, that data is immediately accessible to other processes on that system. That's where the term global comes from. The data is globally available. So in my little demonstration here today, I'm going to be using sort of random data to illustrate some points. This data is not related to any real application data. So here's the global A. Global names must start with a caret. And this global has 3 subscripts, and it's storing the value 4. Now, this is array syntax, but it's best if you learn to picture globals as trees. So I'm going to draw the tree for this global. So the tree has a root, child, grandchild, great-grandchild, and that's a leaf, and the 4 is stored there. The other nodes in the tree exist. There's just no value stored there. There's no data at those nodes. But we can continue to manipulate this global. So we can give an already existing node some value. And that would go here. We can add a new node. And that would go here. And if we want, we can give the root a value. And that would go over here. So how do you actually do this in code? Well, for languages such as Java and .NET, we have what we call the native API. The native API gives you a set method for putting things into a global. There are several getters for pulling information out of a global. If you want to remove information from a global, you use the kill method on a node. And if you kill a node, it wipes out that node and all of its descendants. So if you kill the root, you destroy the entire structure. But if you killed this node, it would basically snip the tree. I'll just put a little X here. It would snip the tree at that spot. That branch and all of its data would be removed. But we're not going to do that. We're going to leave that branch around. Now, as you can see in this tree, some nodes have data only. Some nodes have data and descendants. And some nodes have descendants only. The native API provides another method called isDefined that basically tells you what's going on at any node in the tree. And it does that by returning values 11, 10, 1, and 0. If the 10's digit is equal to 1, it means there are descendants. If the 1's digit is equal to 1, it means there's value stored there. So if we called isDefined on the root, it would return an 11, meaning there's descendants and there's a value. Same thing for this node. There's a value, there's also descendants. This node, however, just has descendants, so isDefined would return a 10. And for the 2 leaves that just have data, isDefined returns a 1. If we called isDefined on a node that doesn't exist, like A of 99, we would get a 0. 0 means no data, no descendants. The node does not exist. Globals are very flexible in the values that they store. We're just storing simple strings and integers, but you can store any kind of numeric value. You can store binary data. You can store lists of values or sets of values. The list structure could come into play if the A global was actually part of a real application and we were storing demographic information about people in the global. So we could have a node 6 that's stored in a structured list format, the name, email, date of birth, phone number, etc., for a person. And the next person would be stored at node 7, and the next person at node 8, and so on. And we could store hundreds or hundreds of thousands of people in this global. There could be another global where we store hundreds of thousands of appointments, and still another global where we store hundreds of thousands of test results. Now, the flexibility of globals extends to the subscripts. We've been using integer subscripts, but you can use non-integer subscripts, strings, floating point numbers, negative numbers, whatever you want. So I'm going to draw a different global, global B, that uses non-integer subscripts. Again, random example here. And we'll give even the root a value. So again, this is the array syntax, but now I'm going to draw the tree for the B global. So if you look at the A global and the B global side by side, they're very similar. They're storing the same values. But the difference is that in this global, hello is to the left of world because 1 is less than 5. But in this global, hello is to the right of world because sun comes after planet. And what am I really talking about here? Subscripts of globals, any subscripts, are automatically sorted. Numeric subscripts sort numerically. String subscripts sort in alphabetical order. And this is automatic. In a moment, you'll see another example that's a more realistic usage of string subscripts. The data in globals is protected in the same way as our other models. So we have concurrency control. If there's a process that's editing the data, the demographic data here in node 6, other processes can't edit the data in node 6, but they could edit the data in other sibling nodes like 7 or 8. We also have transactions control. We can take a set of changes to one or more globals and either commit them as a group or roll them back as a group. Now, as I said at the beginning, these examples are silly random examples just to illustrate some points. But now we're going to take a look at a more realistic example where we're going to take some JSON data that is sort of arbitrarily schemaless structure, and we're going to store it in a new global, the C global, and the tree structure of C is going to match the JSON structure. You don't have to do it that way, but that's our example. We're also going to have two other examples, D and E, which are index globals for some of the data that we get through JSON. So as you can see, here's an example of some JSON data for someone named John Smith. He's got an address. He's got 2 email addresses, his name. And we assign him the ID of 1, and we store his data in the subtree below node 1. The D global is going to be an email address index. It's storing John's 2 email addresses and his ID. And the E global is going to be a state and city index, and that's storing John's state, city, and his ID. The next person that we get data for is Mary Jones. We assign her the ID number 2. Now her data is different. She's got an email address, but her street address is just a single string. It's not separate JSON objects like John's, but that doesn't matter. She's also got an array of phone numbers. So all this data is added to the C global to the right of John's data because her ID 2 sorts after his ID 1. Her email address and ID is added to the D global to the right of John's email addresses, but her city and ID are added to the E global to the left of John's city since they live in the same state. The next person, Lena, comes in. Her data comes in. She's assigned the ID 3. She has an address with the same structure that John has. She's got an email address and a name. She also has a cell phone number. It's not an array. And she's got a date of birth. So her data is added to the C global to the right of Mary's data because her ID is number 3. And her email address and ID are added to the D global in between John and Mary's emails. But her state and city are added to the E global to the right of John and Mary's state and city. So to summarize these 3 globals, the C global is sorted by integer ID, and new entries in that global will be always added on the right. But the D and E global are indexes. The new entries to those globals are always added in the proper position to maintain the sorted order. And some of the things we talked about before in the native API, the isDefine method could be used to determine if a particular email or state-city combination exists in the system. And the iterator can be used to walk these index globals in sorted order. So I started off this presentation by saying that globals are one of the storage models provided by InterSystems' Iris data platform. But in fact, they're so flexible and powerful, maybe you guessed this already, they're actually at the core of all of our models. So when you store objects, that data is stored in a global. When you store rows and tables and the indexes for those tables are updated, that information is stored in globals. When we store JSON, like you just saw, or XML structured data, we store that data in globals. Even our product documentation is stored in globals, including indexes that speed up the online searching. Lastly, globals are so flexible that you can use them to build other structures that your application might need, like linked lists, queues, graphs, and others. So that's all I have to say today about globals. If you want more information, you can check the online doc, read up about globals or the native API. There are also other online resources that you can use. Now, do you think you could learn to love globals? I think the answer to that is yes. Thanks for listening, and take care.